Alright, so the chapter 3 review is all on radicals. This will be a good review. It covers like not a ton of stuff, there's not a lot of radicals that come up, but you guys will see probably one thing. The first thing was just kind of a review of simplifying radicals, where we had square roots and cubic roots. So if anybody needs to remember for your perfect squares, right, something times itself gives you a perfect square. And when we look at exponents, your perfect squares need to be even numbers. That's like a big deal. They have to be even exponents. Right. So when we go to simplify something, what we want to do is think about what's the biggest perfect square that goes into 108. Okay, so we want to get like these type of numbers. 36, let's try it. So 108 divided by 36. Fantastic, love it. Good answer. So this is going to be 36 and 3. And what's 36 become? 6, 3. Good. These get kind of messy, so I like to circle this stuff. Okay, just make sure you guys are organized with that. Now, when you are looking at your exponents, right, we need the biggest even one that goes into 5. So what's the biggest even number? 4. Yeah, good. So x to the 4th, and then what would be left? X to the 1. Good job. Okay. Now remember, when you guys have square roots, there's like a secret 2 out here that we don't see. So when you want to go to reduce, whatever the perfect square, you can always just divide these, and it will work. So if you divide 4 over 2, what would that just become? X good squared, right? Yes, good. So that's going to go out to the front. Now, if you already have it, even exponent right off the bat, like this y is an 8, right? You can do that right at the very beginning. This is like a 2, this is an 8. So what's that going to become? 4, right? Y is a 4. Perfect. Just at the end, make sure everything is organized. So anything that does not have a radical around it will go to the front. 6x squared y to the 4th. Right, and then under my radical, you still have a 3 and a the 1st. Okay, so this would be simplified. Do you guys kind of remember this? It's been a long time, I feel like, since we've reduced radicals. Right, why don't you guys try the next one? Would you guys get the biggest one that goes into 24? 4? Good. Yep. 4. And the 4 is the perfect square between the 2. What about a to the 4th? A squared. Good job. Very nice. So this is an even exponent. Now that b to the 7th, not even, so we need to break it down. What's the biggest even number? 6. Good job. Okay, so we got b to the 6th, b to the 3rd. Okay, that b to the 6th, remember the secret 2, so if we divide those, it's just going to be b cubed. Very nice. At the end, we should have a 2, a squared, b cubed, and then underneath, we have that 6 and a b. Square roots are pretty good. I feel like you guys are good at those. It gets a little bit confusing. I don't know if I've ever seen a cubic root show up on an exam. Not to say they can't do it, but when you guys see that cubic root out in the front, thinking has to like change. So when you see those perfect cubes now, okay, we have a couple numbers that come up a lot. The 8, 27, 64, and 125. You don't have to memorize those. But what you could do to get to 8 is like 2 times 2 times 2. Like do it 3 times. Then 27 was 3 times 3 times 3. Do you guys kind of remember getting those? Like you don't need to memorize them, but like if you did 4 times 4 times 4, you get 64. So you don't. The perfect square? Yeah. So if you want to just do something times itself, so do 2 times 2 is 4, right? 3 times 3 is 9. 4 times 4. So you can like make the list yourself. You're just multiplying it by itself twice if it's a square. If you're doing a cube, you're doing it 3 times. You can always like come up with those. You don't have to memorize it. Just for these multiples of 3, we're gonna look for. So multiples of 3 are like 3, 6, 9, 12, 15 exactly. Right. So that's what multiples of 3 means.
look at 8. Okay, do we have a perfect cube that goes into 8, or is 8 a perfect cube? It is, good.
It's just 2, very nice. Because 2 times 2 times 2 would give us 8. Now, when we look at the 6, is 6 a multiple of 3? Good. So we can do that same little trick. If we divide these, what would you get? Good job, Nancy. Very perfect. Oh, alright, is 4 a multiple of 3 though? No. So at least this one we gotta break up. What's the biggest one that's gonna go in? Cubes, good job. Right, and then we'd have a y to the first box. Oh, I can't forget my little cubics out here. Alright, so the only one we could break down is this y cubed. If you divide those, it's just y. Yep, so 2x squared y, cube root of y. Don't forget your little cubic root out here. Okay, no pain in the box. How was that one for you guys? Not too bad?
Do we have to put the 2 on the other one on the outside?
No, because you'll never see it. It's like a secret hidden 2. But anything else besides the 2, we're gonna set it out there. When we add or subtract radicals, make sure you guys have the same number underneath the radical sign to do it. So like here, these are not the same, so you can't just go through and start subtracting and adding. You got to break them down first to get them to be the same. So these are all squares. So the first thing you want to do is break them down. So you want the biggest perfect square that goes into all the radicals. Anybody think they know 48? Good job. So 16 can become a 4. Good. What about 27? Good job, I like it. 9 and 3. 9 becomes a 3. And then, oh, wait a second though. Oh, good job, we have something on front this time. So, here you have a 5, this 9 is a 3. Angie, what did you have to do with those? Multiply, good. So this is really going to be 15 radicals, really. Tricky. Okay. What about the 75? 25 is a nice job. 5 and 3, so 25 is a 5, and same deal. No, we got to multiply those to get a radical 3. Nice. So once you have the same thing underneath all the radicals, okay, now it means that you guys can actually add or subtract the coefficient. So we want to do what's 4 minus 15, and then we'll add 10. Would you get negative 1? Good job. So it's just negative radical 3. If you want to do negative 1 radical 3, that's okay, you can do that too. You probably won't see the negative 1, it's probably just like negative radical 3. Right, we've done a ton of these kind of problems because this is what you guys will probably see the most deal with radicals. Right? For example, 5. Okay, anytime you guys have a radical in the bottom, you can't do it. It's really bad. Okay, so we have to do that thing called rationalizing. Right? And when you rationalize it, there's 2 terms you want to multiply by the conjugate. Does anybody remember what the conjugate would be with? Good job. 3 plus radical 3. Awesome. Right, just the middle sign only changes. So what we're going to be doing is in the test, right, we have to take that 6 and bring it through. And then do you guys have to do the whole FOIL on the bottom? Just first and last. Good job. Alright, so why don't you guys see, put your hand there. I'm going to make sure we can reduce to it. We need to do our little partner. We get 18 And you do this one, and then 6 radical 3, and then on the bottom, when you guys do your first and last, that'll be 9. Watch your sign. Negative times positive is a negative. This is a little tricky. Radical 3 times radical 3. What would that just give you guys? 3. Good. So here we can make this into a 6, and then watch your reducing. That little heart method. Okay. You want the number that goes into all 3, so 6. Good. Goes into all 3. So this one will be left with a 3. This is a 1 and a 1. So just make 3 plus radical 3. How was that one for you guys? Good. So far, are we like remembering a lot of this? And then, I put this one on just because it's a little bit different, a little bit, I think, tougher with the math portion. Same deal, you guys have a radical in the bottom, there's 2 terms. It's really bad, we don't want that. So we have to multiply by the conjugate again. But when you guys do your multiplication, it's a little bit tougher. So when we do our multiplying, we want to multiply by 3, radical 3 plus 1. Now these two are conjugates of each other in the bottom, so this is just the first and last. Yeah, good answer. You have to do FOIL on the whole top still, because these are not conjugates of each other. So we have to do the whole thing, which is, the math is just a little bit longer. These are first, we get 3. The outers are going to give you guys a good. If you want to write like 1 radical 3, that's okay. Same thing with the inners. You get a 1 radical 3. What's the last one we give you guys? 1. Good. All right. Awesome. Now, in the bottom, when you guys just do your first and the last, what do you get? Good. 3 minus 1, which is 2. Awesome. So let's simplify everything we can. So this is just going to be a 2. Andrew, what are you thinking in the top?
4 plus or 2 radical.
Good job. Nice work. This middle portion, when you guys have the same thing underneath the radical, we can add them. So like 1 plus 1 is going to give us 2 radical 3. Okay. And then the last step is to make our little heart. And write this. 4 plus 2 radical 3 over 2. Okay. So 2 can go into all of these. We're going to be left with a 2 radical 3. Yeah. I feel like you've done a ton of these on your CRs. Like we really did that a lot. Now if you guys just had, actually, let's say you have just something like 3 over radical 5. I know I didn't put this on yours. I should have. Something like easier like this. Do you guys remember how to get rid of the radical on the bottom? It's just 1. Good, times it by radical 5, so you rationalize, just multiply it by itself. Then we get 3 radical 5 over, perfect. Yeah, I should have put like an easier one like that on yours, didn't think about it. You do that so much in like all the trig stuff, I feel like we could do it forever here. Okay, now example 7 is a little bit different than the one I just gave you guys, right? You do have a radical in the bottom, but what do you have in the top also? Another radical. So here, I know a lot of people are probably gearing up like just to rationalize, but think about what does a fraction really mean? What does that mean, Ryan? What kind of like operation is a fraction? Division, good. This is really division. So why don't we see if we could divide this and make it a little bit easier and then simplify? So let's see if we divide these. What's 108 divided by 6? 18, okay. Now, when we are dividing exponents, what do you guys do with those? Subtract them. Good. Right, you'll be able to see that now. Good. X to the 4th. Okay, and y to the 3rd. Perfect. Okay. So now, once you guys divide, especially because this is all divided by evenly, there's no radical up in the bottom. But this does say simplest radical form. Good, yeah. So we're back to like what you guys first did. Yes. Exactly, Ashley. There's a little 2 out here, so you're doing perfect squares. Andrew, what do you think for 18? Right. This becomes a 3. What about x to the 4th? Right? Yes,
cube, you need the biggest even number to, and then y to the fourth. Good, this is one. They're so fast. Good job, Andrew. 3x squared y, radical 2y. I always, just be careful, I always like forget when I look back through, it's like so much junk. Alright, and the last two is something I think that you guys, they come up on every single one. Alright, these are really big. The radical equation. So with your steps for radical equations, you want to make sure you get the radical alone. So get it by itself first. So in here, what do you guys need to move? This 2. Bring that 2 over. Good job. Yeah, okay, so 5 plus 2 is 7. Now, once you guys get the radical by itself, we're going to square both sides. And make sure we can only do this when there's an equation, when there's an equal sign. I know a lot of people want to square, like whenever they see radicals to get rid of them, but you can only do that with equations. When you guys square a radical, the radical goes away, and we're left with 2x minus 3 equals 49. Perfect. So now what we're going to do is solve this like a usual equation. So, good job. Alright, and you got, well, what'd you think here? How did that go for you guys? Good. Now, the way they're going to try to trick you guys is catching people. You need to check into the original, okay? This isn't like a busy work check. This is a check to make sure you don't have to reject something. So, you could do a radical check. Yeah, you could just do it on a calculator. So, yeah, to make this easier, go ahead into your calculator and you can just do your second square root and what we're going to do. So I would just put it 2 times, was it 26? And then minus 3. Just make sure, like, where the radical stops, tab it over to make sure the minus 2 is out of it. And that thing, it should equal 5. It does. So this one's good. Alright, so that works. Now, if they want to be nasty, and this is what I keep seeing like more often than not, is one that's similar to this, where they're going to try to trick you guys. Let's just kind of think about this one. What we need to do first. And good subtraction. I really like it. Yeah. And now we have x minus 3. Is there a radical by itself? No. Yes. Good. Okay. So we can go to squaring both sides. When we square the radical, it goes away. What do we need to make sure we do here? Write it out twice and FOIL it. Okay, this cannot be x squared minus 9, right? Make sure you guys don't bring it through. You have to write it twice. Okay. Right, and then you really need to make sure you're FOILing over here. And they're going to try to trick people not solving correctly. You gotta do the whole FOIL, it's not conjugate. Watch your signs, so make sure negative sign, negative is positive sign. Sign stuff, yes? I know, so yeah, one wrong sign is like a mess. Okay, then combine your like terms if you need to. There's some, there's much. Oh, good, okay. Are we all in the green step or beyond? Okay, so when you guys have an x squared and you want to solve for x, what does this need to be equal to? 0 first. So make sure your x squared is positive when you guys go to factors. So I would subtract 5 and add the x over. So this is going to give us x squared minus x plus, good. So yeah, oh, this is kind of a nice one, better than the bad factor one. What are you guys going to use for your factors? 4 and 1, good. What, and you want a negative 5.
Negative, good job. Alright, so your last step, when you set it equal to 0, right, sign changes to x equal 4 and x equal 1. Make sure though we need to do the check and make sure both of these work. We don't need to reject one, both, especially because see how in here, in your multiple choice, they give you like the option for both, the option for one, or the option for none of them working. So usually, and when you guys do your check, make sure we're doing this in both spots, like the 4 here and the 4 here. 4 check?
Yeah.
Oh, 1 does it? Oh yeah, 1 does not check. So you can't, you gotta reject the 1. Right, only 4 checks here. Okay. Yeah, because when you guys put your 1 in, oops, that's 3. That's going to give you the square root of 4, which is 2, but 2 plus 3 does not equal 1, so that's 5. See how they would be tricky with that last one? Yeah, this is an easy one, I think.